question number 32. The function g is defined as g of x equals, I see two pieces that make up my graph. That means that this is going to be a piecewise function. So when I graph this guy, I'm going to have to go into the lobster key. Wow, best of luck to me drawing a lobster. Here we go. I don't know, whatever. Okay, we're going to have to go into the lobster key to graph our piecewise function. So the first piece is going to be an absolute value function when x is less than -2. And then it's going to be a little parabola between -2 and 2. Okay, so let's graph it. We're going to go into our calculator. Let's clear it out. And I'm going to go to a graph. When I'm in the graph, I hit the lobster, and I'm going to go to the piecewise function. Since I have two functions that I'm looking at, I'm going to pick the one with two boxes. I'm going to type the first function, and that one's the absolute value. Go back into the lobster, get your absolute value bars, x plus 3. And then to type your inequality, you're going to have to go over to the box that's to the right of the comma, and you're going to type in x. And then to get your inequality symbol, you're going to go control equal, and that will give you x is less than -2. Now I'm going to the second piece. Okay, on the second piece, it's going to be x squared plus 1, and then my inequality is from -2 to 2. So this is what my graph looks like. So it looks like I have an absolute value v that stops at -2. So from -infinity to this point here, Bertram is walking downhill. He gets to the minimum, and then he starts walking uphill a little, and then he stops. Now on here, it's not totally obvious what kind of points I'm putting at the end of these pieces, right? On the inequality symbol here, I have x is less than -2. So this is going to be an open circle. So Bertram is walking. He gets to the end of the absolute value function, and he can't stay there. When x is -2, he needs to be up here, and he jumps up onto the parabola, okay? So the parabola, he can certainly stay at -2. That's fine. There is a closed circle there. And then he keeps going until he gets to the end of the parabola when x is 2. And if you'll notice from the inequality symbol used in the question, he can also hang out at the end of that parabola. That's going to be a closed circle. So let's get our points here, okay? We can do menu 5, 3. We're going to tell it what to count by. And then we do menu 5, 1. And then just be careful with piecewise functions, right? So it'll tell me the points this way. So -9, 6. Let's go ahead and put that on the graph. -9, 6. 1, 2, 3, 4, 5, 6, 7, 9. 1, 2, 3, 4, 5, 6. Okay. What else? -6, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. -4, 1, 1, 2, 3, 4, 1, 2, 3, 4, 1. And then our minimum is at -3, 0. And then it curves up. And it looks like, did you notice what just happened there, right? We got to the minimum, and then the graph didn't tell us where Bertram can walk up to, right? It stops at -3, but it doesn't tell us what Bertram's doing at -2. And we need to know where to put that open circle so Bertram knows where he needs to jump. So let's look at -2 and see what y value that would be. That would be a y value of 1. So I need to put my open circle, right, where x is -2, and then 1 up, I'm putting an open circle, okay? So my absolute value function ends there, and it keeps going from -infinity. Remember, look at the graph. Bertram is walking all the way from -infinity. So let's label that. And let's do the second piece of our absolute value function. Okay, so let's get that second piece. So the second piece, it's x squared plus 1, so it's going to be a quadratic going from -2 to 2. So I go to the graph, and and I'm going to put two closed circles, and let's start graphing our parabola. So -2, 1, 2, 3, 4, 5. That's my first point. Oh, I should have waited to write that. Oh no. I'm just going to move it. Okay. So -2, 1, 2, 3, 4, 5. And then -1, 2. And then 0, 1. And then 1, 2. And then 2, 5. I'm putting a closed circle on the end because at -2 and 2, Bertram can stay. No arrows on the end of my graph because the parabola is stopping there. Okay, that's it. Wait, what happened?